Hi folks, welcome to the lesson solving simultaneous equations by elimination. We're looking at the easier types. There's a second video with more difficult examples, but we're starting with the easier types, so let's crack on and get this job done. Okay, this looks really easy. 3 plus 5 equals 8, correct? Correct. Now, if we have those two equations which have got numbers in them, if we add the two equations, look what we get. 3 plus 2 is 5, 5 plus 4 equals 9, 8 plus 6 equals 14. But the actual statement we've got, 5 plus 9 equals 14, is correct. That means we can add equations together, and when we add them, it makes a third equation, which is still true. If we take those two equations that we started with, and this time subtract them, what do we end up with? 3 subtract 2 is 1, 5 subtract 4 is 1, 8 subtract 6 is 2. We end up with a third equation or a third statement, 1 plus 1 equals 2, which is true. Let's look at equations with letters in. If we take these two equations, note, we can just look at the equations and say, oh, well, y has to be 2 in both equations. Well, if we add the two equations, what do we end up with? 4 plus 2y equals 8. And if we solve that bottom equation, 4 plus 2y equals 8, we still end up with y equaling 2. Therefore, adding equations does not change the values contained within those equations. So let's apply this to two simultaneous equations. Straight into example 1 then. The first thing we do, let's number the equations 1 and 2 so we know what we're talking about. In order to eliminate one of the letters, we need the same number of a particular letter. Now, in this example, we've got 1x and 1x, and we've got 5y and 3y. So because we've got the same number of x's, that is the letter we're going to eliminate. Now, because it's in both cases, it's a positive 1x, as in the signs are the same, they're both positive. If the signs are the same, we subtract the equations. So just remember that if the signs are the same, you subtract, and if they're not, you add. So when we subtract these equations, what's going to happen? We're going to have 1x take away 1x, that will cancel out 0x. That's what we want. Then we'll have 5y take away 3y, which will be 2y, and then 9 take away 5, which will be 4. So that becomes 2y equals 4, and from that y equals 2. Great, we found the y value. Now we need to find the x value. So we take our y value and we substitute it into one of the equations. I'm going to substitute it into equation number 1. And when I do, I'll end up with x plus, and then 5y, because y is 2, 5y becomes 10. So I end up with x plus 10 equals 9. And so to solve that, I subtract 10 from both sides, and that gives me x equals -1. I think now I've found the two values that fit both equations. X is -1 and y is 2. Now we can check our answers. If we substitute what we think are the right answers, x equals -1, y equals 2, if we substitute them into the two equations. So in equation 1, x plus 5y equals 9, becomes -1 plus 5 lots of 2, and does that equal 9? Well, yes, it does, because it's -1 plus 10, which is 9, so it fits the top equation. Does it fit equation 2? X plus 3y equals 5 becomes -1 plus 3 lots of 2 equals, and does that fit? Well, -1 plus 6 equals 5. Yes, it does. So let's try this with example 2. The first thing we did, label the equations 1 and 2. Then in example 1, we looked at the letter where you had the same number of that letter. In this example, we've got the same numbers of y's, so we're going to concentrate on the y's. Now they are both plus 1y in both equations, so we will eliminate those y's if we subtract the two equations. If the signs are the same, we subtract. They're both plus y's, they're the same, we subtract. So 5x take 2x is 3x, the y's disappear, and 23 take away 11 is 12. So 3x equals 12, 1x must equal 4. We now need to find the y value, so we substitute x equals 4 into one of the equations, into equation 1 in this case. So 5 lots of x becomes 20 because x is 4. So that top equation becomes 20 plus y equals 23. So y must equal 3. We think those are the correct answers, but let's check. We substitute what we think are the right answers into both equations to see that they fit. In equation 1, if we put x equals 4 and y equals 3, we get 5 lots of 4 plus 3 equals 23. Yep, that's correct. If we put the two values into equation 2, we get 2 lots of 4 plus 3 equals 11. Yep, it's correct. We've got the right answer. Here in example 3, can we remember the process? Number the equations 1 and 2. Have we got a letter where we've got the same number of? Yes, we have. It's the y's. But note, one is a subtract y, one is a plus y. The signs are not the same, so we don't subtract. We have to add the equations. If the signs are the same, subtract. If they're not, we add. So by adding those equations, that minus y added to plus y cancels out. The y's disappear. 4x plus 2x equals 6x. 26 add 16 is 42. Dividing by 6 gives us x equals 7. So we substitute x equals 7 into one of the equations. I've taken the top one, so 4x becomes 4 times 7, which is 28. Subtract y equals 26. Y therefore must equal 2. And we take those two values and we stick them into our equations for a check. And when we come to do our check, 4x minus y equals 26 in equation 1 becomes 4 lots of 7, subtract 2. Does that equal 26? Yes, it does. And in equation 2, 2 lots of x becomes 2 lots of 7 plus 2. Does that equal 16? Yes, it does. We've checked our values. We know they're correct. On to example 4. Number the equations. Which letter has the same number? It's the y, both 1y. And are the signs the same? Yes, they are. They're both subtract. So if the signs are the same, we subtract the equations. 5x take 3x is 2x. The y's cancel, and 11 take 7 equals 4. If you're sitting there wondering, well, do the y's cancel? Let's see. I'm subtracting a negative y. Subtracting the negative is adding the positive, i.e. that becomes plus y. So I'll have minus y and plus y. That cancels out to give me 0y. So 2x equals 4, giving me x equals 2. Substitute x equals 2 into equation 1. 5x becomes 10. Subtract y equals 11. And therefore y would have to be negative 1. So those are my two values. As ever, we check. X is 2, y is negative 1. Substitute it into equation 1. 5x becomes 5 lots of 2. Subtract y means I'm subtracting negative 1. That gives me 10 plus 1. That equals 11. And in equation 2, 3x becomes 3 lots of 2. Subtract negative 1. Subtract negative 1 is adding 1. That makes 7. And finally, one last example, example 5. We number the equations. Which letter has the same number? The x's. Are the signs the same? Yes, because it's positive 2x and positive 2x. When the signs are the same, we subtract the equations. When we subtract the equations, the x's disappear. Just be careful with the y's here. We're subtracting a negative y. Subtracting a negative is adding the positive. So that becomes negative 3y plus y. And negative 3y plus y gives us negative 2y. And 11 take 9 equals 2. So if we divide both sides by negative 2, y equals negative 1. What's the x value? Substitute it into one of the equations. And if we substitute it into equation 1, we get 2x, subtract 3 lots of negative 1. So that's 2x plus 3. Because, why is it plus 3? Because 3 times negative 1 is negative 3, but we're subtracting the negative 3, so that's the same as adding 3. 2x plus 3 equals 11. If we subtract 3, it gives us 2x equals 8, and therefore x equals 4. We think we've got our answers. X equals 4 and y equals negative 1. Do the check. Put x equals 4 and y equals negative 1 into the first equation. 2 lots of 4, subtract 3 times negative 1. Does that give us 11? Yes, it does. And put the values into equation 2. 2 lots of x becomes 2 times 4. Subtract y is subtract negative 1. So that's 8 subtract negative 1. Does that equal 9? Yes, it does. We've got the right answer. Therefore, let's put all this together in a recap. We started off, we always labelled each equation 1 and 2. Which letter are we going to eliminate, the x's or the y's? You eliminate the letter that you've got the same number of. In this example, we've got the same number of x. We're going to eliminate the x. If the signs are the same, then we subtract the equation. So are those x's the same sign? Well, it's a positive 2x and a positive 2x. They're the same sign, so we subtract the equations. We don't bother about these being the same sign because it's the x's we're looking at, not the y's. So we're subtracting these equations, and just be careful when you do this, because the subtracting negative there, the subtracting of negative y is adding y. So you've got negative 3y plus y gives you negative 2y. You do have to be careful. And 11 take away 9 just gives us 2. So that gives us y equals negative 1. We found one of the values. Don't forget to substitute back into an equation to find the x value that goes with that y value. So substitute y equals negative 1 into one of the equations. In this case, I'm substituting it into equation 1. And I end up with that. Be careful with the arithmetic. That subtracting negative 3 is adding 3, so I get 2x plus 3 equals 11. Subtract 3 and divide by 2 gives me x equals 4. And when you think you've got the right answers, put them back into each equation. So into equation 1, do those values 4 and negative 1 fit the equation? Yes, they do. And in equation 2, do the values x equals 4 and y equals negative 1 fit that equation? And the answer is yes, it does. When you've checked both equations and they're both right, you know you've got the question right. And if there's anything about the video you haven't understood, just watch it back. And if you have, that's great, because that's the job done.